Welcome back. We're continuing with all the free response questions, this time 2009 Form B. So we'll be looking at composite functions today. More specifically, trying to get tangent lines of composite functions, given information about their parent functions in the graph of the parent function, and to determine the slope and concavity of composite functions given the parent functions. Okay, so I've got a derivative of a parent function here. F is a twice differentiable function defined in the interval from -1.2 to 3.2. F of 1 is 2. The graph of the derivative is shown. The derivative crosses the x-axis at -1 and -3 and has a horizontal tangent at x equals 2. I want g to be the composite function such that g is equal to e raised to the f of x. I want to start by writing a line that is tangent to the graph of g at x equals 1. What do I have to do first?
G prime 1.
Okay. So for tangent lines, I need g prime, and I need what else?
And G1 value, and yeah, that's it.
Alright, so what can I do for g prime 1?
Prime 1 is e to the fx power times f of x.
Okay, so I'll need to know what g at 1 is before I can do that. What is f at 1?
F at 1 is 2.
2. And what is f prime at 1?
F prime at 1 is
Ah. Okay, I'm gonna jump in here.
-4.
Okay, -4. Said f prime 1 was 2 and sorry, f of 1 is 2 and f prime 1 was -4. Okay, so that makes g at 1 equal to e raised to the f at 1 or e squared. Okay, so what's our equation of the tangent line?
X, well, no, y minus e to the x power equal to -4 e squared.
Okay, y minus, which ones are e squared?
Is equal to -4 e squared times x minus 1.
Awesome. Okay, and for part B, I want to find all values for which g has a local maximum and then justify your answer. So what will have to be true in order to have a local maximum?
So g prime x is equal to 0
Okay. So g prime x from last problem we said was equal to f of x f prime x. So taking a look at this, I want to know whenever g prime x will be equal to 0. So if g prime x, let me move this up. If g prime x is this, when would g prime x be equal to 0?
If the fx is always positive, so we always see, so the only things that we see is f prime x, which is the graph. So at -1, it changes from positive to negative.
Okay. So everything you just said is right. If we had e raised to any number must be positive. If f prime x changes from positive to negative. And he told me that happens only at x equals -1. Okay. Oh, I'll go maximum, sorry. Positive to negative. Okay. So the second derivative is given here. So that's deriving with chain rule. Is g prime prime -1 positive, negative, or 0? And then justify your answer.
So just plug in the we plug in -1. So the first part is to the fx power is always positive.
Mm-hmm.
Then if I plug in -1 and then square it, it's gonna be positive.
Hmm.
Then f double prime -1 is the slope.
What is f prime 1 or f prime -1?
F prime -1 is 0.
0. Okay, so this isn't positive, this is actually 0 for this term.
Oh, and then f double prime -1 is slope is negative, so we can know it's negative number. Then yeah, so it's negative because we multiply by positive.
Cool. So I'm going to write this out mathematically and have you help me out. So we said Okay, we said this so far. Um, so we're going to write this out again. Mathematically, what can we say about this first part?
So, I don't know how to say. I would just write the equation and then write the signs and zero.
Okay, you told me e to the f of x has to be positive. So this is e raised to the f at -1 will be greater than 0, for instance. And f prime at -1 must be what?
Zero.
Must be equal to 0. Okay, and then you found concavity by looking at f prime as well. So you said f prime was what?
Negative.
No, f prime you told me was 0, but f...
Oh, yeah.
What about the second derivative of f, though?
Isn't it the slope?
Okay, it is the slope of f prime, which is the graph that's showing. So should it be positive, negative, or 0?
Negative.
Negative. Okay, how did you know?
Because the derivative, I mean the double derivative of f is the slope of f prime x.
Okay, so I'm going to write something like, as f prime at f prime is decreasing, about x equals -1. The second derivative of f at -1 is negative. Okay, so what can we finally conclude about g prime at -1?
G prime at -1 is less than 0.
Awesome. So g prime at -1 must be negative, because we've got a positive times a negative, effectively. Okay, and last one. Find the average rate of change of g prime over the interval 1 to 3.
Oh, average rate. So it's g prime 3 minus g prime 1 divided by 2.
Okay, and then we'll have to substitute. So we need g prime 3 first.
And then we know the equation from above.
Okay,
So g prime x is, yeah. And then we already know, yeah, g prime 1. So we have to find g prime 3.
okay. So we need f of 3 and we need f prime 3 for this. What is f of 3?
F of 3. F of 3.
Mm-hmm.
F of 3. Wait, is it 0? No, oh. Isn't it the same value as -1? No, no, no. Wait, F3? You cannot know exact number, right?
Okay, I see f prime 3. 1. Okay, we know we've got a maximum there. I don't think it's going to matter. So I don't think we can find f of 3 exactly, but I think when we multiply it by this f prime 3, that's going to be 0 anyways, so it'll cancel out. I was going to try to estimate, but I don't think we need to. Okay, I'm just going to write it out. So f of 3. I think you're doing the same thing, right? So you're trying to estimate with me? Yeah. Okay, we do know this part though. Is the f of 1 times f prime 1? Which we said was this, negative 4e squared. And then divided by 2. Okay, so what should our final answer be?
Oh, it's 2e squared.
2e squared. Okay, that all looks good. So let's score really quick. Okay, so we've got tangent line, y minus e squared equals negative 4e squared times x minus 1. Okay. That was 3 points. So g prime x, g1 and g prime 1, and the tangent line. Okay, then 1 point for the answer and justification. Okay, x equals -1 because we're changing from positive to negative. We've got that. Okay, so local maximum and then justification. Answer justifications. We've got concavity is negative. We're decreasing around that. Okay. Decreasing around that. Concavity is negative. Okay, that was good. It's really both of those lines. Then this one. And last part. Difference quotient in an answer of 2e squared. Difference quotient 2e squared. Awesome. Okay, any questions on anything from today?
So homework is
Okay, so for the homework, we've already done the first question on this one earlier. So I'm going to give us the ones we haven't done. So this is 2, 3, 4, 6 from 2009 Form B. And I will post them to a chat in a minute.